Signal can search for and detect features in waveform data using the built-in active cursor functions. Measurements from detected features can then be plotted automatically to an XY view as displayed on the right. Up to 10 cursors, numbered 0 to 9, are available in the frame, and individual cursors can search any channel for features of interest. Cursor 0 acts as the iterator cursor. When it searches for and finds new features, all other active cursor positions are updated in response. For this reason, cursor 0 is nearly always used to find a common reference around which other features can be found by additional active cursors. Cursors are created and active mode set from within the cursor menu. A common requirement is to detect action potentials in a recording. Cursor 0 is always available, so in this example we can go to active mode in the cursor menu, and set cursor 0 to search channel 1 for peaks that have an amplitude change of 50 millivolts. Minimum amplitude is the level that the waveform must rise before and then fall after a peak to be classified. This allows accurate detection of peaks on data with a baseline drift. Maximum width will reject peaks that are too broad. We will leave it at 0, which sets no restriction. The minimum step field will reject any other peaks that occur within this time range. You can check your settings by holding down Ctrl and Shift and using the left and right arrow cursor keys. This steps cursor 0 between waveform features in the frame that match the search method. Now that cursor 0 is set to find the peaks, we can set additional active cursors to find other features. In this example, we'll set up cursor 1 to find the after hyperpolarization, or AHP, of the action potential. Using the trough find search method, in the time range between cursor 0 and cursor 0 plus 20 milliseconds. Setting the minimum amplitude level to 10 millivolts. For the trough find search method, this sets how far the data should fall before and rise after the trough to be detected. Again, we can check the feature detection using Ctrl and Shift and the right arrow key. To output the results of measurements, select Measurements from the Analysis menu XY View option. In this example, we will set up a measurement of the peak-to-peak amplitude. The Settings dialog includes a section that defines the stepping mode for cursor 0, using the current active mode for the cursor if already set. The Start at and End at fields set the time range in the source data from which to take measurements. To set a title for the plot channel, edit the text in the field. Our X measurement takes the time at point of cursor 0 for each step, the time at which each action potential occurs in the data file. Our Y measurement takes the peak-to-peak amplitude between cursor 0, peak, and cursor 1, AHP, for every step. Click New to create the XY view and show the process dialog. Here we set the frames to take measurements from. Taking measurements from the current frame in our source file and clicking Process gives the plot shown here. Right-click on the XY view to make changes to the settings and add additional plot channels. that will measure value at point of cursor 0, peak, and measure the value at point of cursor 1, the AHP. Apply these changes to our plot, and process. The measurements function will generate up to 32 plot channels holding the results of different measurements. And you can set different colours per channel for the display. To export an XY view to a spreadsheet, use the Copy as Text command from the Edit menu, and paste the data to a text file. I hope this has given you a useful introduction to taking measurements from data in Signal.